Hey guys, welcome back. So we are going to be moving on to a new unit. Now we've finished out reactions, and we're going to move on to our next unit, which is called quantitative chemistry. So quantitative means that we're going to be taking measurements. So now we're going to be still doing reactions, but we're going to be taking measurements while we do reactions. So we're going to be measuring out, like, oh, if I react 5 grams of this with 5 grams of that, how much product do I make? Okay. Now, as we go through this, there is going to be a little bit of math, but I promise you it's not hard math. There's nothing more difficult than multiplication and division in this. And really it's going to be mostly just conversions, okay? We've already done a whole bunch of different conversions at the very beginning of the year to kind of prepare for this, okay? So we're going to be doing mostly just converting, okay? So we're going to go through chemistry with measurements. So recall, we've been focusing on reactions in chemistry, and really chemistry is all about reactions, okay? So that's why we're going to be focusing kind of the rest of the year on reactions. So in this unit, we are sticking to reactions, but focusing on determining the quantity or mass of products in reactants during a reaction. And what I mean by that is the idea of saying, okay, if I burn, say, 100 grams of methane or natural gas, if I burn 100 grams of this, okay, how much oxygen do I need for perfect combustion? Okay. If I'm going to be designing, say, a Bunsen burner, or if I'm going to be designing a furnace, okay, and I know how much methane I'm going to be burning in that furnace, I have to figure out, well, how much oxygen should I be releasing in order to make a perfect combustion? Because remember, if I go short, and if I don't give it enough oxygen, it's going to burn dirty. Okay. Along with that, it'd be handy to know, well, how much CO2 am I going to be producing? Like, how many grams of CO2 am I going to be producing? And how many grams of water am I going to be producing? Okay. So this is what this next two lessons is really going to be all about, and it's going to be even more than just the next 2 lessons, is figuring out this, okay, is if you take 100 grams, okay, just knowing that you need 100 grams of methane, you can figure out all of the different amounts that you would need of oxygen, CO2, and H2O, how many grams of each of those you would need in order to have this perfect reaction. So we can talk about easy quantitative chemistry. So you may think, well, this seems pretty easy because I know the conservation of mass. We're basically saying, okay, if I took something like 5 grams of this and I took 10 grams of this and it perfectly combined, well then of course I'm going to have 15 grams of this because matter can't disappear if I take 10 grams of this and 5 grams of this and combine it. Okay? But remember that we have to combine things in perfect ratios. Remember when we do the crisscross rule, I can't just take sodium and chlorine and then just make sodium chloride. That doesn't work, okay? Remember, I have to go Na plus 1, chlorine minus 1, and do my crisscross rule. Remember, this is going to be Cl2, and we have to balance our equations. So you can't just kind of say, okay, if I want 15 grams of sodium chloride, that's going to be 10 grams of chlorine and 5 grams of this. You have to, we're going to be going through the calculations. We're basically saying, if you want 15 grams, how many grams of this do you need? And how many grams of this do you need? It will add up to 15, but do I need 10 and 5, or do I need 15 grams of chlorine and 0 grams of sodium, and so on? Right? So quantitative chemistry always requires balanced chemistry equations. If we're going to be able to do this, we have to balance the equation. Now, most of the time, I'm going to be giving you the balanced equation just because it's a different task altogether to even balance an equation. It can be frustrating if you can't do it, but whenever you're going to be doing these calculations, you have to balance a chemical equation. And up here, the chemical equation is not balanced, okay? So if I wanted to balance this, I would have to put a 2 in front of there and a 2 in front of there, and now it's balanced, right? And it's a balanced chemical equation. So you can see that while I would actually need twice as much sodium as I would need chlorine in order to make this happen, because there's a 2-to-1 ratio, okay? And the last thing is just, we know this from grade 9 and grade 10. The mass of the products must equal the mass of the reactants. Okay, total mass on this side must equal total mass on that side. Now, this would be easy quantitative chemistry. And why I said that is, if I said that you had 15 grams on the left side, you know that you're going to have 15 grams on the right side. But let's take a look at a question that we would be doing in this course, because it's a little bit more difficult. Something like this. What if you had 200 grams of water, and you're going to break this apart, okay? And you're going to break this apart into hydrogen and oxygen gas, okay? Well, you are not going to get an equal, 100 grams of this and 100 grams of this. That doesn't happen, okay? it would be very easy if chemistry was like that, but that's not how it works, okay? What you actually have to do is you have to do a whole bunch of different calculations, and that's what we're going to go through, and it's actually more complicated than may originally seems. You have to do a whole bunch of calculations to figure out, okay, well, I would actually get something like, these are just hypothetical, but say 140 grams of H2 and 60 grams of oxygen. Okay, it's still going to add up to the 200 grams because that's got to add up to the 200 grams, but it's not going to necessarily be equal. Okay, and that's what we're going to go through in these questions, is trying to figure out, well, exactly, if they're not going to be perfectly equal, how much do I have of each? Okay, and that's what I have down here. Quantities are not always equal. So there's the example kind of I gave at the beginning, is if you had 100 grams of this, how much oxygen do I need to burn with it? How much CO2 am I going to produce? And how much water vapor am I going to produce? Okay? You only really need to know one value, and then you can figure out all the different values. Okay, so the key in this is if the equation is balanced, you only need to know the mass of one reactant or product. Then using calculations, you can determine the masses of all other products and reactants. And this process is called stoichiometry. So if I wanted to know all the different amounts that I need for this reaction to happen, all I need to do is to have a balanced chemical equation, which I do here, and then I need to know one amount. Okay? So say if I know this amount, I can get all the other ones. Okay? If I didn't know that one and say I knew this one, then I can figure out the amount of water and oxygen and methane. If I didn't know that one, if I knew this one, okay, I could still figure out the amount of methane, the amount of carbon dioxide, the amount of water. You only need to know one amount, and through the calculations I'm going to show you, you should be able to figure out everything else. Okay, so stoichiometry is a skill in chemistry where you can complete the mathematical calculations in order to determine the amount of products and or reactants in a chemical reaction. Now, what we're doing is we're kind of going through what a chemical engineer would do. Okay? Because what a chemical engineer would do is, say you're going to make an aspirin tablet. Okay? So over here, this is what aspirin is. Okay? You may have had an aspirin tablet before. And the job of a chemical engineer is saying, okay, if I'm going to make 150 milligram aspirin tablet, okay, how much of these products am I going to need to order in my factory in order to make that one tablet? Like, do I need, 100 grams of this and 25 grams of this, and then I'm going to make actually 25 grams of, that math isn't that up, so I'll change this to say 50. And then I make, 175 grams to make everything match up. Right. Basically figuring out, do I need 75 grams of this and 100 grams of this? And if I use those, combine those together, this is what I get. Right? That's what the job of an engineer is, to really kind of go through that math and to figure that out. Right. So what I have here is, if you're going to make, like, say you want to make 100 grams of salt. So say, we don't do this, but say you were opening up a plant and you were going to make salt. Okay? And you wanted to sell your salt in 100-gram packets. Okay? Then what you would have to do is you would want to figure out, in terms of being able to make money, well, how many grams of chlorine am I going to need to buy, and how many grams of sodium am I going to need to buy? Right? Well, before you have to do that, you're first going to have to balance this. Right? And then once it's balanced, now we're going to go through some calculations. Okay? So the first thing we got to do is we have to do some balance. The next calculation we're going to do, we're going to have to convert mass to a number of atoms. If I want to know how many grams of chlorine is over here, I have to know, well, how many atoms of chlorine are over here. Okay? And it may look like, well, there's two, but there's not really two atoms. Okay? That's just the chemical equation. What I have to do is I have to figure out, well, if I have 100 grams of, say, sodium chloride, okay, and that 100 grams breaks apart, and now I have a bunch of chlorine atoms, how many chlorine atoms is it? Okay? And how many sodium atoms is it? So we have to convert mass to the number of atoms. We have to convert this mass, 100 grams, into how many atoms is 100 grams. Okay? Once we know those number of atoms, okay, then we can say, okay, if there's that many atoms over here, if there's that many chlorine atoms on this side, so say there is 1 billion, okay, chlorine atoms on this side, then there must be 1 billion on that side. Okay? So then that's our next step, is we determine the number of atoms in each product and reactant. Once we know the number of atoms, then we convert the number of atoms back to mass. So really what we do is we kind of go mass to atoms and then back to mass. So that's the idea behind stoichiometry. Okay, now this is going to be probably 4 different lessons because it's multiple different steps. Okay, so this is kind of the start of kind of understanding as to why we're doing this. Okay, so this lesson was more based around kind of why are we doing this. Okay, and the next lesson will be on how we do it.